Question number 48. The first statement, reaction between ammonia and an alkyl halide gives a mixture of primary, secondary and tertiary amines and a quaternary ammonium salt. This is a true statement. Let's look at the mechanism of ammonia reaction between ammonia and alkyl halides. Let's say this is our alkyl halide. Let's take an example for this so we can understand that easily. Let's say our alkyl halide is CH3Cl. Since it is polar, this will be plus, this will be delta minus. So the lone pair on the nitrogen will attack this carbon. It's a nucleophilic substitution reaction. This chlorine goes and the ammonia joins with the carbon of the alkyl halide. So we will end up with, let's say, CH3. Now we have N plus and 3 hydrogens are there. Then a water molecule will remove a hydrogen. The hydrogen will leave its electron onto the nitrogen to neutralize the plus charge. This is how the reaction ends in a primary amine. This is called a primary amine. Primary amine. Now this produced primary amine has also a lone pair, so it is also a good nucleophile. Like this ammonia. Ammonia is also a good nucleophile. This ammonia. So if the alkyl halide is present in the solution, it can react with this CH3NH2. So this CH3NH2 primary amine will also act as a nucleophile and attack the alkyl halide. Since this is delta plus, delta minus, lone pair on the nitrogen will attack the carbon, chlorine will be removed. It's a nucleophilic substitution. So this will end up with, now this group has 2 hydrogens and a CH3 group. Then a hydrogen will be removed by leaving its electrons to neutralize the plus charge on nitrogen. That's how we end up with a secondary amine. Now this secondary amine is also a nucleophile because it has a lone pair on the nitrogen. It can also attack the alkyl halide. This is a secondary amine. Now when this secondary amine reacts with the alkyl halide, let's see what happens. There's a lone pair here. This is the alkyl halide. The lone pair on the nitrogen can attack this carbon. The chlorine will be removed. Then we will end up CH3N plus. Now this nitrogen has a hydrogen and 2 CH3 groups. So the hydrogen will be removed by leaving its electrons to neutralize the plus charge on the nitrogen. That's how we end up with tertiary amines. Now tertiary amines can also react with alkyl halides because it has a lone pair on it as well. It is also a nucleophile. Now this is a tertiary amine. Now when this tertiary amine reacts with the alkyl halide, the same thing happens, nucleophilic substitution. The lone pair on the nitrogen will attack the carbon here. Chlorine will be removed. So it's a substitution. CH3N. Now there are 3 CH3 groups. Since there are no hydrogens to be removed, this compound will stay as it is. This is called a quaternary ammonium salt. quaternary ammonium salt. So the first statement is correct. Reaction between ammonia and alkyl halide gives a mixture of primary, secondary and tertiary amines and a quaternary ammonium salt. That is true. This is the complete mechanism of the reaction. The second statement, primary, secondary and tertiary amines can react as nucleophiles. That is true. And that is the reason that we got all these products from the reaction between ammonia and alkyl halides. So the answer for the 48th question will be the first one. Okay, let's move on to the next question.